This is a video on absolute extrema. The question states, find the absolute extrema over the triangle with vertices 0, 0, 4, 0, and 0, 4 of the function f of xy is equal to x plus y minus xy. So let's sketch a picture. Here's the triangle with vertices 0, 0, 4, 0, and 0, 4. It has edges y equals 0, x equals 0, and the equation of this line segment is y equals 4 minus x. It has slope -1 and y-intercept 4. So I'm going to use the theorem that says that a function has absolute extrema either at a critical point or on the boundary. So f of xy is certainly differentiable, so critical points of f will occur only when the gradient is 0. So I set the partial derivatives equal to 0. F sub x is 1 minus y, and I set that equal to 0. And f sub y is 1 minus x, and I set that equal to 0. And I get x equals 1 and y equals 1. So a critical point occurs at the point 1, 1. So now let's look at the boundary. On y equals 0, we can plug in 0 for y, and we get x plus 0 minus 0, or f of x is equal to x. F prime of x is just 1, and that doesn't have any zeros. So that means that on this line segment, the max and mins have to occur on the boundary or on the vertices of the triangle. Similarly, at x equals 0, f of xy is equal to y, and that's derivative is also 1. So there are no critical points on this boundary, which means that the extrema must occur at the endpoints or the vertices. For the third boundary, y equals 4 minus x, I plug in 4 minus x where I see y, and I get x plus 4 minus x minus x times 4 minus x. I can simplify that to x plus 4 minus x minus 4x plus x squared. If I take a derivative, I get -4 plus 2x. And if I set that equal to 0, I see that x is equal to 2. If x is 2, y is 4 minus x. 4 minus 2 is 2. So I get the point 2, 2, which is a critical point of f on the boundary. So that tells you that my absolute extrema must occur either at the point 1, 1, at the point 2, 2, or at any of the vertices of the triangle, 0, 0, 4, 0, or 0, 4. So now I just set up a table. I look at the points where the absolute max or min can occur, and I plug in those points into f. If I plug in 1 and 1 for x and y, I get 1 plus 1 minus 1 times 1, that's just 1. If I plug in 2 and 2, I get 2 plus 2 minus 2 times 2, and that's 0. If I plug in 0, 0, I get 0 plus 0 minus 0 times 0, and that's also 0. If I plug in 4, 0, I get 4 plus 0 minus 4 times 0, and that's 4. And if I plug in 0, 4, I get 0 plus 4 minus 0 times 4, and that's also 4. So now I just look at f and see where are the biggest numbers and where are the smallest numbers. We see that 0 is the smallest number that f achieves. So 0 is the absolute minimum. And I see that 4 is the largest value that f achieves. So 4 is the absolute maximum. So I can conclude that f of xy has an absolute minimum of 0 at the points 2, 2 and 0, 0, and an absolute maximum of 4 at the points 4, 0 and 0, 4. And I'm done with the problem.